Hi everyone, and thank you very much to subscribe my channel and supporting me a lot. And the thing is, I'm getting watch time more, right? So if you have, please comment below. Whatever your requirements from my educational channel, so I'll try to fulfill them, right? So coming to, let's start. I said already previous videos we have discussed about the heat, but we have discussed a few problems, right? So here in this video I'll try to solve only one problem which makes you understand entire content of the heat lesson, right? So listen and watch carefully. If you have any doubt, just rewind it and watch again, or else just you simply comment below. I'll give the clarification, right? Thank you all. Let's get into the topic. So here I'll explain my content by explaining the problem, right? Now let us see the problem, right? Let me read the problem first of all from the 10th standard textbook, right? The problem is, how much energy is released or absorbed when 1 gram of steam at 100 degrees Celsius turns to ice at 0 degrees Celsius, right? Can I read again? How much energy is released or absorbed when 1 gram of steam at 100 degrees Celsius turns to ice at 0 degrees Celsius? Now let's write given data, right? So what's the question? How much heat energy would be released when 1 gram of water, that means mass of the substance is 1 gram, and the next thing is steam at 100 degrees Celsius. Steam in the sense gaseous state, right? So at 100 degrees Celsius there is a gaseous state, right? Now this gaseous state converted into 0 degrees Celsius of solid state, which means ice, right? So can I explain in the once again? 1 gram of 1 gram of water vapor which is at 100 degrees Celsius converted into 1 gram of ice at 0 degrees Celsius. సో అంటే గ్యాసియస్ స్టేజ్లోంచి సాలిడ్ స్టేజ్లో కన్వర్ట్ అవుతుంది. సో ఇలా కన్వర్ట్ అవుతున్నప్పుడు ఎంత ఎనర్జీ అనేది రిలీజ్ అవుతుంది లేదా అబ్జర్వ్ అవుతుందో కనుక్కోండి అన్నాడు. అబ్జల్యూట్లీ ఎనర్జీ విల్ బి released when gaseous substance is converting into solid substance, isn't it? So now here let's solve this problem. By solving this problem you will get a lot of content from this lesson, so concentrate well and get a clarify, and I can tell you that after listening this you no need to buy this chapter again, right? So here first let us see, let's consider 100 degrees Celsius gaseous state, right? So here we have learned in the previous video, right? So here you have to remember that when the gaseous stage is, first of all let's see the stages. 100 degrees Celsius of water vapor directly, it doesn't convert directly into solid state. There are number of stages. First thing that you have to remember, 100 degrees Celsius of water vapor which is in the gaseous state doesn't convert easily into solid state. There will be certain process for it. So now let's see that process. First what happens? First, at a constant temperature, means at 100 degrees Celsius the gas will convert into liquid state at 100 degrees Celsius. Here temperature will be constant, but when you are taking energy from the 1 gram of water, then what happens? The gaseous substance will convert into liquid substance. It's clear, right? So next, coming to after again if you try to take energy from the substance, then here the liquid substance will be remained as liquid, but temperature decreases to 0 degrees Celsius, right? And after next stage, in this stage again the temperature will be constant, but the liquid stage will convert into solid state. Clear? right? So here this is what they're asking in the question: how much energy would be released when 100 degrees Celsius of gaseous state, 1 gram of water vapor will convert into 0 degrees Celsius solid, right? So now here 100 degrees Celsius gaseous state directly will not convert into solid state. There are three states. In the first state, the temperature of the substance will be constant, but while releasing the energy, the gas will convert into liquid state. And the second state, while releasing the energy, the state will be the same, but the liquid temperature decreases to 0 degrees Celsius, right? And the third stage, the liquid will be at constant temperature, the liquid converts into solid. So this is the process, right? So now here let's try to calculate how much energy will be released in the first state, second state and third state, right? So we know well-known formula for heat energy. What is that? Q is equals to Sm delta T. The heat absorbed by or gained by any object or substance will be equal to the product of its mass and change in its temperature, right? So here this formula that can be used when there is change in temperature, right? So now here let me find out first of all in this stage. So the heat energy released in the second stage will be equal to specific heat of the water and mass of the water 1 gram and the change in temperature. What is the change in temperature? 100 degrees Celsius temperature change to 0. That means the change in temperature is 100. So now so that the heat energy released is 1 into 1 into 100. That means 100 calories. So here in this condition, when 100 degrees of liquid changes its temperature to 0 degrees Celsius, then how much energy would be released? 100 calories of energy. In the same way, the liquid which is at 0 degrees Celsius, if you give 100 calories of heat energy, then its temperature increases to 100 degrees Celsius, right? So now, okay, it's fine. By using this formula, you can calculate in this stage. What about in the first stage? Q1. If you use same formula Sm delta T, right? So 100 degrees Celsius in the sense of water vapor, right? The specific heat of the water vapor, let us imagine one, and the mass is 1 gram and the change in temperature. Here you must remember that there is no change in the temperature, right? The temperature of the substance is constant from 100 degrees Celsius to 100 degrees Celsius. But what is happening here? The energy is utilizing to convert the substance. We have learnt already what is boiling. The process of converting a liquid into gaseous state at constant temperature is called boiling. Why don't temperature rises at boiling point? Endukante here the given heat energy will be the given heat energy will be useful to break the bonds between the liquid molecules, and then liquid will convert into gaseous state, right? So here in this process the same thing will be happen. What is that thing? Here when the gas is converting into liquid, the energy will be utilized to create the bonds. When the energy is releasing, then all the gaseous molecules come close together and they leave the energy. Then what happens? The temperature will be constant, right? Right. So now here, so that by using this formula you cannot calculate the required heat energy or the releasing heat energy to convert 100 degrees Celsius substance to 100 degrees Celsius. That means when there is no change in temperature, right? The same scenario you will face in another place also, where here in the third stage. In the first stage there will be no change in temperature, so you cannot use this formula. In the second stage it's okay. In third stage, again there is no change in temperature. Here what happens here? The liquid is converting to solid, but the temperature is constant. If you use this formula, change in temperature will become 0. Means 100 minus 100, 0. 0 minus 0, 0. So there is no change in temperature. If you use this formula, the final result will be 0. But in reality, is it really 0? No, right? When one substance is, when you give heat energy, then only liquid can convert into gaseous state. In the same way, when you take heat energy from the gaseous state, it converts into liquid, right? Definitely there will be some certain amount of heat which releases or observed when its state changes. Then how to calculate that energy? So it's very clear that we cannot calculate by using this formula. Then which formula that we have to use? We have to use Q is equals to L into M. So what this formula? Latent heat of vaporization or latent heat of fusion. The scientist latent, what he has done is experimentally found that when the substance is changing its state at constant temperature, how much would be the required heat energy or released heat energy. So by using that experimental value, we are going to calculate this, right? So for water, it's take 540 calories for 1 gram of water. What is the latent heat of fusion? The required heat energy to rise the 1 gram of water at constant temperature from one state to another state is called latent heat of vaporization, and its value is 540 calories, right? So here L value will be 540 calories into L into M. L in the sense latent heat of vaporization, and M in the sense the mass of the water, 1 gram. If they give 2, we can write it for 2 grams. So 540 calories. 540 calories of heat energy releasing when 1 gram of 100 degrees Celsius water vapor is converting into liquid at 100 degrees Celsius, right? Now we have calculated the first state, second state. The third state, same formula we have to use. Q is equals to L into M. Here also same scenario, there is no change in temperature, so we cannot use this formula. So for that, what we have to use? We have to use latent heat of fusion. Here it is latent heat of vaporization, and here it is latent heat of fusion. So in this scenario, when the substance is when the liquid is changing into solid at constant temperature, the required heat energy, right, is nothing but latent heat of fusion. So this value is 80 calorie per gram, right? So now L is equals to 80. So I think so it's very clear that, right? So 80 calorie per gram. So 80 into mass of the substance 1. So 80 calories. If they give 2 grams, you have to substitute in the place of M 2. So now the total energy released when 1 gram of water at 100, water vapor at 100 degrees Celsius is converting into 0 degrees Celsius is Q1 plus Q2 plus Q3. So that what is Qn? 540 plus 100 plus 80, right? 540 and 100, 640. 640 and 80, that will be 720 calories. I hope you understand well, right? So from this topic we can learn that two things. What are they? Latent heat of vaporization and latent heat of fusion, right? Thank you all. And still, if you have any doubts or to solve these kind of problems in your textbook or any extra material, please ping to me or comment below.